Hello everyone, my name is Nikita. I am from EC branch. My subject is data structure and my topic is infix to postfix conversion with examples and implementation in Python. Stack is a list of elements in which an element may be inserted or deleted at only one end, called the top of the stack. The elements are removed from the stack in the reverse order of that in which they are inserted into the stack. Stack is also known as the last in first out approach or push down list. Before understanding the conversion from infix to postfix notation, we should know about the infix to postfix notation separately. An infix and postfix are the expressions. Expression consists of a constants, variables, and symbols. Symbols can be operators or a parenthesis. All these components must be arranged accordingly to set off to a set of rules, or that all expressions can be evaluated using the set of rules. All the above expressions have the common structure, that is, we have an operator between the two operands. An operand is an object or a value on which the operation is to be performed. In the above expression, 5, 6 are the operands, while plus and minus or stars are the operators. What is infix notation? When the operator is written in between the operand, then it is called infix notation. Operand does not have to be always a constant or a variable. It can also be an expression itself. For example, p plus q star r plus s. In the above expression, both the expressions of the multiplication operators and the operand, that is p plus q and r plus s, are the operands. In the above expression, there are three operators. The operand for the first plus operator are p and q, and the operator for the second plus operator are r and s. While performing the operation on the expressions, we need to follow some set of rules to evaluate the result. In the above expression, addition operation would be performed on the two expressions, that is p plus q and r plus s. Then the multiplication operation would be performed in between both the operands. Syntax or operand, operator, operand in is the syntax for infix notation. If there is only one operator in the expression, we do not require applying any rule. For example, 5 plus 2. In this expression, addition operation can be performed between the two operands 5 and 2, and the result of the operand would be 7. If there are multiple operators in the expression, then some rules need to be followed to evaluate the expression. If the expression is 4 plus 6 star 2, if the operator is evaluated first, then the expression would be 10 star 2 is equals to 20. The first performance is given to the parenthesis, the next performance is given to the exponent. In the case of multiple exponent operators, then the operation will be applied from left to right. After exponent, multiplication and division operators are evaluated. If both the operators are present in the expression, then the operation will be applied from left to right. The next performance is given to addition and subtraction. If both the operators are available in the expression, then we go from left to right. The operators that have some precedence termed as operator associative. If we go from left to right, then it is also known as left associative. And if we go from right to left, then it is known as right associative. To evaluate the infixed expression, we should know about the operator precedence rules. And if the operator has the same precedence, then we should follow the associativity rules. The use of parentheses is very important to infix notation to control the order in which the operation to be performed. Parenthesis improves the readability of the expression. As infix expression is the most common way to write an expression, but it is not easy to parse and evaluate the infix expression without. So, mathematician and lo- logicians studied this problem and discovered two other ways to write expression which are prefix and postfix. Both expressions do not require any parenthesis and can be without ambiguity. It does not require operator precedence and associativity rules. Applications of style. Converting algorithm expression from one form to another form. Infix to postfix, infix to prefix, prefix to infix to postfix, infix to postfix, postfix to prefix, etc. Evaluation of postfix expression, parenthesis balancing in compiler, depth first search, traversal of graph, recursive applications. Expression evaluation and syntax parsing, backtracking. The prototypical examples of the backtracking algorithm is depth first search, which finds all vertices of a graph that can be reached from a specified starting vertex. Books kept one above another, matching parentheses by compiler to traverse a word. An undo mechanism in text editor, stack of books, push down automata, memory management, evaluating prefix, postfix, and infix expressions. Infix expression. The expression of a form A operator B, A plus B, which an operator is in between every pair of operand. Postfix expression. The expression of the form AB operator where the operator is followed by every pair of operand. The postfix expression is an expression in which the operator is written after the operand. For example, 2, 3 plus. Some key points regarding the postfix expression are: in postfix expression, operations are performed in the order in which they have written from left to right. It does not require any parenthesis. We do not need to apply operator precedence rules and associativity rules. Algorithm for postfix expression is: scan the expression from left to right until we encounter any operator, perform the operation, replace the expression with its computed value, repeat the step from 1 to 3 until no more operators exist. For example, we'll start scanning from left most of the expression. The multiplication operation is an operator that appears first while scanning from the left to right. Now the expression would be 2 plus 3 4 star. Evaluation of postfix expression using stack. Scan the expression from left to right. If we encounter any operand in the expression, then we push the operand into stack. When we encounter any operator in the expression, then we pop the corresponding operands from the stack. When we finish with the scanning of the expression, the final value remains in the stack. Read a character. If the character is a digit, convert the characters into in int and push the integer into the stack. If the character is an operator, pop the elements from the stack twice, obtaining two operands. Perform the operation, push the result into the stack. The compiler scans the expression either from left to right or from right to left. Consider the expression a plus b star c plus d. The compiler first scans the expression to evaluate the expression b star c. Then again scans the expression to add to it. To add to it. The result is then added to d after another scan. The repeated scanning makes it very inefficient and infix expression are easily readable and solvable by humans, whereas the computer cannot differentiate the operators and parentheses easily. So it is better to convert the expression to postfix or prefix from before evaluation. The corresponding expression in postfix form is abc star plus d plus. The postfix expression can be evaluated easily using a stack. Steps to convert infix expression to postfix expression using stack. Scan the infix expression from left to right. If the scanned character is an operand, output it. Else, if the precedence and associativity of the scanned operator are greater than the precedence and associativity of the operator in the stack, or the stack is empty, or the stack contains a open parenthesis or closed parenthesis, then push it. Operator is right associative, and other operators like plus, star, minus, division are left associative. Check especially for the condition when both operators at the top of the stack and the scanned operators are power. In these conditions, the precedence of the scanned operator is higher due to its right associativity. So it will be pushed into the operator stack. It also the it in all the other cases when the top of the operator or when the top of the operator or stack is the same as the scanned operator, then pop the operator from the stack because of left associativity, due to which the scanned operator has less precedence. Else, pop all the operators from the stack which are greater than or equal to the precedence than that of scanned operator. After doing the push the scanned character after doing that, push the scanned operator to the stack. If you encounter parentheses while popping, then stop there and push the scanned operator into stack. If the scanned character is an open parenthesis, push it into the stack. If the scanned character contains an closed parenthesis, pop the stack and output it until a open parenthesis is encountered, and discard both the parentheses. Repeat step 2 and step 6 until the infix expression is scanned. Print the output. Pop and output from the stack until it is not empty. The time complexity is big O of n, where n is the size of the infix expression. Auxiliary space is big O of 1. Here is an example of converting infix to postfix expression. The rules are print the operand as they arrive. If the stack is empty or contains a left parenthesis on the top, push the incoming operator into the stack. If the incoming symbol is an open parenthesis, push it into stack. If the incoming symbol is an closed parenthesis, pop the stack and print the operators until the left parenthesis is found. If the incoming symbol has higher precedence than the top of the stack, push it on the stack. If the incoming symbol has lower precedence than the top of the stack, pop and print the top of the stack. Then test the incoming operators against the new top of the stack. If the incoming operator has the same precedence with the top of the stack, then use the associativity rule. If the associativity is from left to right, then pop and print the top of the stack, then push the incoming operator. If the associativity is from right to left, then push the incoming operator. At the end of the expression, pop and print all the operators of the stack. Thank you.